Hi, my name is Tarun Arora, and today I'm presenting my project for the Generative AI class. So for the project, I tried to build a multi-page Streamlit application that helps the user to upload their CSV file, clean the CSV file through interacting with user through chatbot, and then use the cleaned CSV data file to provide plot suggestions for data visualization, as well as provide the code and the plot as per the user's request. So I started the first part of the project by building a LangChain based agent with conversational buffer memory and tools that can help the users to clean the CSV files. The key differentiating factor here from other approaches is that the LLM model, directly does not access the CSV files. Rather, the tools that can modify these CSV files to clean them only have access to the contents of the CSV file. This method is very different from while I was discovering on the implementation of the project, I found that there exists an inbuilt CSV data loader by CSV LangChain agent by LangChain. But the only key differentiating factor is that you would have to pass your whole CSV file. However, in this case, you don't have to pass your CSV file to the model. Rather, it is just there with just there, just the tools can access them, which in some sense uh, enhances data privacy. So before I go on and show how the project work, I would love to take you through the code and the way I implemented the project. So starting with the My CSV agent, first I ask the user to upload a CSV file. Upon uploading the CSV file, I make sure to store the CSV file as a data frame variable in the session state. It is important to do so because Streamlit refreshes after every refreshes and reruns the Python file after every user interaction, and we do not want to just lose track of all the changes being made to the CSV file when we are cleaning it. So it is necessary to do that. When I did not attempt to store it in the session states, it actually resulted in just keeping the track of the last change made, which is something that it was undesirable. After that, I just started building the tools for my CSV agent. The tools have two crucial components. The docstring, which with docstring and the function name helps the LLM decide which particular tool to go to as per the user prompt. And the way we return the information helps the LLM to provide the necessary information to the user. Now I created different tools like tools to check null values, tools to fix null values using median, tools to fix null values using median where two columns should match, and etc. One of a few more unique tools were whether to how to check data anomalies, whether there are any columns that have repeated values, detection and fixing outliers, and check and removing duplicate rows and checking if there are any highly correlated columns in the data set. At the end, I just bind the tools with the LLM and create an agent. I also provide, as I said, I also provided the agent with the conversational buffer memory, and at the end, I basically provide the user with a feature to download this clean data set, which can be further used in the second part of the project. Before going to my approach in the second part, I like to show that only the tools here get the access to the session state of the data frame, not the model itself. The model is just initiated uh, just initiated to be the to be with to be GPT 3.5 turbo with a temperature of 0. Now moving to the second part of the project, which was suggesting users what plots they can make, as well as providing the code for one of that plot and the plot itself. So for that, I first created a prompt that would ask the that would just uh, ask the user to upload the clean data, ask the user if there is anything specific they want, and then based on that create the output describing what all suggestions should be, what all suggestions are crucial for visualizing the data. It was very important here to use st cache underscore data because in order to keep the sessions constant throughout the application. Like for example, if we are working through the application, we need the suggestions to remain the same, not get refreshed any time I click on any other button. Moving forward, the second main task was to figure out a prompt that could give me error-free code, which could then generate a plot. So for that I used the CoStar prompt engineering technique, which turned out to be really great as I was able to generate the code and then uh, run the exact same code without any human intervention. After that, I just basically display the code and display the code as well as display the plot. So for the CSV agent, first you upload a CSV file. I created this CSV file using GPT-4 where I specified a set of rules that I wanted to follow so that I can test all of my tools that I have built for the LangChain agent. So let's say, are there any null values? Okay, so let's say fix the null values in the rent column by median where bathrooms column and sorry, where bedrooms column and rooms baths column should. So it should hopefully call the null, like fix null median using the two columns that specified, and it does that. Let's say drop the rest of the null values. And it says that, oh, it now has just 99 rows left. So let's say check for duplicate rows to see if there are any. And let's say let's fix these duplicate rows. Now let's try to, so it basically found the two duplicate rows and removed them as well. Now let's see if it could catch the correlation between the two columns that are highly correlated in our data set. Uh, can you fix correlated columns? So it identified and dropped one of the highly correlated columns and it mentions that this column has been dropped. And let's say, are there any columns with uh, all values same for every row? Let's say, can you extend column? So it does that. And lastly, let's just check, uh, can you detect outliers? So it detects two outliers and let's say, yes, outliers. Oh, so now for the outlier code, I believe that, yep. So for the fixed outlier code, we need to go about it like with respect to every every column. So I think we need to mention that I need to fix the outlier values using median. So it actually fixes them. So this is the point I think where maybe if I enhance more tools it should fix, because it does not quickly pick that, oh, fix the outliers means that I should call fix median. Rather it detects the outliers in this particular function. So I think that's one drawback that I could notice right now. And let's say, for example, let's click finish and proceed to download. So download data as CSV. Oh, now coming to the second part where I'll just upload the clean data that we got from the first part. So we can ask for any suggestions that we want. So for example, we want to see, so for example, if you don't want to give any suggestions, we can just type none, and it will provide some generalized suggestions for us, like bedroom versus rent, and it gives us good number of suggestions. So for example, uh I want to see how rent varies in, like, what's the average rent in a county. So we can say that, okay, oh, oh yeah, so we can say average rent in each county, and then it should hopefully produce the code as well as the plot. So by this we can play around with this, change these factors, and come up with more interesting things. But yeah, the main catch in this particular one was to how to use cache underscore data, as otherwise it would just keep on, like if I select a different column, it will keep on changing the suggestions irrespective of every interaction. So it's always better to cache in this, for especially for the suggestions function. And yes, that's pretty much it for my project. I hope you liked it. Thank you so much for your time.